All right, 16b, here's some more improper integrals. These are the kind where it's not that we have a limit of integration that's infinity or negative infinity, it's that we have a function that is undefined somewhere over the interval of integration. Both of these functions, 1 over x and 1 over x squared, are undefined at 0. So I have to rewrite this as the limit, as, again, you can use t or a or b if it's upper. I'm going to use t. T approaches 0. Now t is actually approaching 0 from the right, which doesn't always matter, but it's worth noting, right? If I'm between 0 and 1, right, I'm on the number line between 0 and 1. If I'm in here, I'm definitely on the right side of 0. So we're approaching 0 from the right. Of the integral from t to 1 of 1 over x dx. So if we look at this, it's the limit as t goes to 0 from the right. No, actually, integral 1 over x is the natural log of the absolute value of x from t to 1. The limit as t goes to 0 from the right of the natural log of 1 minus the natural log of t. I dropped the absolute values because both 1 and t are positive because t is approaching 0 from the right side of 0, which is the positive side. You could also write the absolute values, that wouldn't be a big deal. So this is going to be 0. And now as t approaches 0 from the right, what happens to the natural log function? Well, if you recall, the natural log function looks like this. So if I'm approaching 0 from the right, the natural log function is going down, 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 down to negative infinity. This is actually going to be negative infinity, which is infinity. So it's kind of crazy. Both the integral from 0 to 1 of 1 over x diverges, and the integral from 1 to infinity of 1 over x diverges. So we'd say this integral from 0 to 1 diverges. If we think about this graphically, it means, so if we look at the function 1 over x, which is this kind of thing, right? From 0 to 1, what we're saying is this area here, right up there, it goes on forever and ever, it's an infinite amount of area. Okay, let's look at the integral from 0 to 1 of 1 over x squared. So if you recall, the integral from 1 to infinity of 1 over x squared converged to 1. So we're going to do the same kind of thing we did over here, now over here. So this will be the limit, as I'll use a this time. A goes to 0 from the right still, because we're between 0 and 1. Integral of 1 over x squared, which is x to the minus 2. That's going to be the limit as a goes to 0 from the right. Integral, oh sorry, forgot those. Integrate this, you get x to the negative 1 over negative 1, which is just negative 1 over x from a to 1. Plugging in into integration, limit as a goes to 0 from the right. I get negative 1 over 1, which is negative 1, minus negative 1 over a. So I get the limit as a goes to 0 from the right of negative 1 plus 1 over a, or 1 over a minus 1. As a goes to 0 from the right, 1 over 0 blows up to infinity. So this goes to infinity minus 1, which is infinity. So this integral also diverges to infinity. Which again kind of makes sense because if you think about the graph of this, it's kind of the same as that. Here's 1 over x. 1 over x squared is just a little bit steeper, but still kind of is the same thing. So we're still looking at kind of this, which ends up being infinite. So what kind of integrals do converge where you have like an undefined point in between limits of integration or at one of the limits of integration? Well, here's an example. The integral from 0 to 9. It could have been 0 to 1, but I said something different. Of 1 over the square root of x. So we look at this. You have the integral from, I should just write this, the limit as t goes to 0, still from the right, because we're between 0 and 9. Integral from t to 9. I'm going to mark this as x to the negative 1/2 dx. So the difference between this one and the previous one is what's going to happen is when we integrated this one, x to the negative 2, we still got x to a negative power. Right? The integral was x to the negative 1, which gave us an x in the denominator. When we integrate this one, we're going to end up getting x to a positive power, which is going to be in the numerator, and it's not going to be a problem to plug in 0. So let's see, I've got the limit, t goes to 0 from the right. I guess I'm actually integrating this now, so okay, fine. So I get the limit, as t goes to 0 from the right. Integrate this, you get x to the 1/2 divided by 1/2 between t and 9. Simplify this as 2 times the square root of x. Keep the limit as t goes to 0 from the right of 2 root x from t to 9. Plug in the 9. So limit as t goes to 0 from the right of 2 square roots of 9 minus 2 square roots of plug into t. And good thing we're approaching 0 from the right, because t should be positive. We're taking the square root of it, right? You can't approach t from the 0 from the left with this kind of function. And we get 2 times 3 minus 2 times 0, which is just 6. So this integral converges to 6. Anything else I want to say about that? No, not really. I would encourage you to look at the graph of 1 over the square root of x. I actually don't have a good idea of what it looks like in my head. I know it's undefined at 0. I think we have like a vertical asymptote to it. But yeah, it's kind of funky. Yeah, you should look at the graph of it.